Hi there, welcome to Stainless Scholars Academy, and in today's video we'll be looking at implicit differentiation. Now, implicit differentiation, you must have also heard about explicit differentiation. Now, explicit differentiation, an example of an explicit differentiation, something like this: y equals 5x squared plus 2x plus 1. This is explicit. You can see that y is alone here, and then you have the x terms and your constant there. But when you talk about implicit differentiation, meaning it means that you have inside of it the function of y, okay, not just a single variable function, but a two variable function in that function. Okay, so the first question we're going to look at and see how we can solve it is implicitly will be x squared plus y squared is equal to 25. Now, we want to differentiate this. We want to find the y dx. You are given this, we want to find the y dx, or we want to differentiate this or find the derivative of this. Now, we're going to differentiate this. If you differentiate x squared, you're going to have 2x. Now, if you differentiate y squared, you're also going to have 2y. But now, the thing about implicit differentiation is that you must add the y dx to any function of y you differentiate. Now, we differentiated x where we got 2x. Yes, we leave it like that. Then, differentiating the function of y, we must add the y dx to the back. So, now if you differentiate 2y, it becomes, if you differentiate y squared, sorry, it becomes 2y. But you must add the y dx to the back of the y function. Now, it's equal to, if you differentiate 25, 25 is a constant. If you differentiate 25, you get 0. Okay, so now we're going to leave every term that has the y dx by our left hand side and take any other term by our right hand side. So this becomes 2y dy dx to be equal to, take this here, becomes minus 2x. Now we're going to differentiate both sides by 2y. So dy dx is going to be equal to minus 2x over 2y. So 2 takes away 2. We're going to have that our dy dx is going to be equal to minus x over y. Okay, so if we differentiate x squared plus y squared is equal to 25, we're going to have it that our dy dx will be minus x over y. Okay, so this is another question we're about to solve. Find the y dx given 2y to the power of 3 plus 4x squared minus y is equal to x to the power of 6. Okay. Now, if we differentiate this, we're going to have 3 times 2. That gives us 6y to the power of 2. But don't forget, you must add the y dx to the back of any function of y you differentiate, because this is an implicit differentiation. So it becomes dy dx, 6y squared dy dx. Now, if we differentiate this, of course, it will simply give us 8x. Now, if we differentiate this, if you differentiate y, you get 1. But you must add the y dx to that one. And that one is going to be invisible because 1 times the y dx gives us the y dx. So it becomes minus dy dx is equal to, differentiate this, you're going to have 6x to the power of 5. Okay. Now, we're going to leave every dy dx term on the left hand side and take every other term to the right hand side. So this becomes 6y squared dy dx minus dy dx is equal to 6x to the power of 5 minus 8x. Okay, so now if you check, the y dx is common here. We're going to bring 1 out, so this becomes the y dx into we're going to be left with 6y squared minus 1 here, so equals to 6x to the power of 5 minus 8x. Okay, so now we're going to divide both sides by 6y squared minus 1 because we want to find the y dx. That's our aim, to find the y dx. So finally, the y dx, by the time we divide both sides by this to find the y dx, it becomes, the y dx is going to be equal to 6x to the power of 5 minus 8x over 6y squared minus 1. So this is going to be our dy dx.